Good morning, students. I hope you are well. So, let's start our chemistry class. So, now we are in lesson number 6. Okay, so of course, chapter 19, we are in chapter 19 from page 614. So, I hope you have studied the previous lessons because they are very important. So, now we will start section 3. Okay, it is oxidizing and reducing agents. So, we took before what is oxidation and what is reduction, and we said oxidation, it is loss of electrons. Reduction, it is what? Gaining of electrons. You should remember that. So now, what is a reducing agent and what is an oxidizing agent? Okay, now let's read the definitions, but I will explain it to you in a simpler way. Don't worry. So a reducing agent is a substance that has the potential to cause another substance to be reduced. Okay, so wait, don't worry, I will explain to you later. Now, reducing agents lose electrons. They attain a more positive oxidation state during an oxidation reduction reaction. Therefore, the reducing agent is the oxidized substance. Okay, wait, don't worry, I'll explain. Now, an oxidation agent is a substance that has the potential to cause another substance to be oxidized. So, you will tell me, teacher, I did not understand. Okay, I will show you a formula now. So, this is a formula. You see here, magnesium plus copper 2 oxide yields magnesium oxide plus copper. Now, you remember also I told you oxidation is what? Also, it's not just about electrons here, it's also about oxygen. So remember that oxidation also is gain of oxygen. Reduction is loss of oxygen. So here, this material you see here, this magnesium, it gained oxygen. So it is now oxidation. The process happened on magnesium is oxidation. And the process happened on copper 2 oxide is reduction. Look, it lost the oxygen and it became copper alone. Here, magnesium gained the oxygen and it became magnesium oxide. So, as you remember, now oxidation is loss of electrons also. Oxidation's loss of electrons. So, now, you should remember that when I say before, when we said a reducing agent, okay, you see, a reducing agent, it is the element or compound that the oxidation process happened on it. So here the magnesium is the reducing agent. You see, now it is a little bit confusing. Again, the reducing agent is the element or the compound that the oxidation process happened on it. This is the reducing agent. Why? Because why they call it reducing? Reduce, okay? It means or decrease. And what's the meaning? Reduce or decrease. What? It reduced what? Why we call this the reducing agent? Because it reduced the oxygen from the copper 2 oxide and it took it. Okay? So that's why we call it reducing agent. Okay? Now, remember this. For the copper 2 oxide, now what is this called? It is called oxidizing agent. You see here? Oxidizing agent. Now why the copper 2 oxide it is called oxidizing agent? Okay, remember the element or compound that a reduction process happened on it. Look, a reduction process happened on it, then it is what? Oxidizing. It is an oxidizing agent. Why it is an oxidizing agent? It lost, now you see, it lost, okay, or it gives the oxygens to the other, okay, to the other element or compound, so it oxidized it. You see, because oxidation is gaining of oxygen. So we call this compound because it gave, okay, it gave the magnesium the oxygen, okay, it made the magnesium oxidized, so we call it oxidizing agent. You see, so you remember from the formula. So you will tell me, teacher, now how should I know? So from the formula, first what should you do? You assign where is the oxidation, where is the reduction process. Don't confuse yourself. Then, okay, the opposite. So the element that an oxidation process happened on it, this is the reducing agent. And the element or compound that a reduction process happened on it, then this is what? An oxidizing agent. And I explained to you why do we say oxidizing agent or reducing agent. Okay, so this is for oxidation reduction. And here also, okay, definition. So you have definition from the book, and here also you have definitions here for the reducing agent and an oxidizing agent. And you remember also that we said a redox reaction is one with both reduction and oxidation. If you have an oxidation process, then you should also, okay, have a reduction process. Look, they are occurring. Oxidation and reduction always occur together. Now, because if something loses oxygen, something else must gain it, and it is similar with the electrons. Okay, so you should remember that. Now, let's continue. So here, the main idea in this slide, so we finished about the oxidation and reduction. Now, we will move about reactivity. Okay, the main idea, the more active an element is, the better it acts as an oxidizer or reducer. Now, you should know from before that there are elements more reactive than other elements. So if this element is more reactive, then it will be a better oxidizer or a reducer. And it depends on the formula and the reaction. Okay, so the higher the reactivity of this element, it is more stronger oxidizer or reducer. So for example, look here, the order of the elements in the activity series seen in the chapter on chemical equations and reactions is related to each element's tendency to lose electrons. Now, elements in this series lose electron to the positively charged ions of any element below them in the series. So here, this one, what's important? The more active an element is, the greater its tendency to lose electrons, and the better what a reducing agent it is. Remember, you see, it lost the electron. So what is the process? Loss of electron. So it is oxidation. Now remember, the element or compound that an oxidation process happened on it, we call it what? A reducing agent. Okay, now, so how do I know from the periodic table? It's easy. Okay, write this rule, please. Write this rule. So if the element is higher in the periodic table, it is more reactive, but there are some exceptions. Okay, so the higher the element is, it will be more reactive than the element below it. Okay, you should know this. Now, for example, you see fluorine is more stronger than chlorine, or more reactive than chlorine. Why? Because it's higher. It's fluorine, chlorine, then bromine. Okay, now, the greater the distance is between two elements in the list, okay, the more likely it is that a redox reaction will take place between them. Okay, you will have a redox reaction, and we will see later an example. Okay, don't worry. And we will see a figure shows the reactivity also, higher activity series. Don't worry about that. So the first figure that we are going to see is this one. Figure 3.1, oxidation reduction terminology. So you should remember that in oxidation, I explained this to you before. Oxidation, loss of electrons. So for example, from Na, it is the oxidation number is 0, yields Na plus 1 electrons. So what happened to the oxidation number? It increases. Okay, now change of electrons, it's loss of electrons. We know oxidation. Reduction, decreases, gain of electrons. Now oxidizing agent, remember, it is the same element or compound that a reduction process happened on it. So do you see? Decreases also, gain electrons. You see, similar to reduction. Reducing agent, it is the element or compound that an oxidation process happened on it. So you see here, same as, okay, the oxidation increases, loss of electrons, okay? You should remember that. So it's important. This figure 3.1, it's important, okay? So let's continue. Okay, now the fluorine atom is the most highly electronegative atom, and you know this. I gave you the electronegativity range before, from the fluorine, the strongest electronegative atom, to the metals, the weakest. Okay, now it is also the most active oxidizing agent. Okay, remember fluorine, so it gains electron, so reduction, so that's why we call it an oxidizing agent. Remember the opposite. Now, because of its strong attraction for its own electrons, the fluoride ion is the weakest reducing agent. Okay, so remember, so we will see a figure. So for example, fluorine is the most strongest electronegative atom. So that's why, okay, it is the strongest or the most active oxidizing agent. But the ion, okay, the fluoride ion is what? The opposite. The weakest what? Reducing agent, the opposite. Okay, so the strongest oxidizing agent, the ion of it is the weakest reducing agent. Remember that. The negative ion of a strong oxidizing agent is a weak reducing agent. Remember the negative ion. You see here, the negative ion of a strong oxidizing agent is a weak reducing agent. Remember. So here, now, the positive ion of a strong reducing agent, remember, so a strong reducing agent, okay, now is what? Okay, the positive ion of it, okay. Now remember, reducing agent, what's the meaning? It means what? An oxidation process happened on it. Okay, reducing agent, it means an oxidation process happened on it. So the positive ion of a strong reducing agent is a weak oxidizing agent. So you should remember these. Now, as shown in figure 3.2, we will see the figure, don't worry. Li atoms are strong reducing agents, okay, because Li is a very active metal. So Li, what is it? Lithium. Now, why do we call it reducing agent? Why? Because lithium, it is a metal, so it tends to lose electrons. But because it is the more reactive, so it is the most strongest what? Reducing agent, or it will oxidize immediately. An oxidation process will happen on it. The strongest one, it is the strongest atom, the lithium. Okay, so that's why, because now an oxidation process happens on the lithium, the strongest one. Okay, what do we call it? The strong, okay, reducing agent. A strong reducing agent. Now, when Li becomes, okay, atoms oxidize, they produce Li plus. You see, now this Li plus, you see, the positive ion of a strong reducing agent here, the Li plus is what? Is weak. Okay, because this is the strongest, so this is the weakest what? Oxidizing agent. Okay, weakest, you see, oxidizing agent. You should remember that, and we will see the list. Now, the left column of each pair also shows the relative abilities of these metals to displace other metals from compounds. So now we have a displacement reaction. We will take it, okay, later. So a displacement reaction, or actually we took it before, sorry, in single displacement and a double displacement. Okay, so one element or compound will displace another. Yes, we took it before. Yes, so for example here, zinc, for example, is above copper. Now remember, the element that is above in the periodic table, so it is more reactive. So the element above will displace the element below. So zinc is a more active reducing agent. It displaces copper ions from solutions of copper compounds. Okay, so now we will see here, let's go to the figure. This is the figure, okay? Now, I will not tell you to memorize it. It is very long. I will not tell you memorize it. It is very long. So maybe I will bring it in the exam and I will ask you, for example, where is the strongest element that an oxidation process happen on it very strong, okay? Which one? You should know. The lithium. It is the strongest reducing agent, okay? It is the strongest reducing agent. So the oxidation process happens on it it is the very reactive, okay? The strongest reactivity series here, lithium, okay? So remember about that. You see, relative strength of oxidizing and reducing agents. So lithium is the strongest reducing agents. But of course, all of this what? In a redox reaction. I am not saying lithium is the strongest reactivity in all elements in any reaction. No, we are speaking in a redox reactions, okay? In a reduction oxidation process, okay? So that's important. Let's continue now. Non-metals, you know non-metals, they are on the right of the periodic table, and some important ions are also included in the series in figure 3.2. You see here, figure 3.2, okay? Any reducing agent is oxidized by the oxidizing agents below it, okay? And you can see here the displacement. You see, you can see here Cl2 displaced, okay? Now the Br2 ions, okay, Br minus 2 ions. So the Cl, you see here, the Cl it took the electrons, it gained the electrons from the bromine. You see, Cl2, it gained the electrons from the, here actually it's a bromide. So the Cl, the chlorine, it gained the electrons and it became chloride, and bromide became bromine, okay? So now, in every redox reaction, there is one reducing agent and one oxidizing agent, okay? In the preceding example. So look, now, here, you see, now, Br minus is the reducing agent. Do you see now what happened? What happened to the Br? What happened? It lost electrons. So oxidation. So what do we call it? The opposite. We call it a reducing agent. Okay. Now the Cl2, what happened? Cl2, what happened? It gained electrons. So what do we call it? You see, what do we call the Cl2? Now, because it's gaining, so it is a reduction. So we call it what? Oxidizing agent, the opposite. You should remember that. So today's lesson is very important. Please study very well. This is the end of our lesson.